I won't make a meal about this thing because everything I'm going to talk about is online. This gets down to RDF's ability to expose the underlying structures and capabilities of existing systems that were heretofore often dealt with as silos because they didn't have a natural way to describe their information and the structure of that information. Most data in healthcare today isn't in relational databases, and a hell of a lot of it's in these mumps-based stores, and Tom spoke a bit about that before. And the people who are dealing with those stores, Tom will say, I'm sure, very intentionally, either way, they created a medium in which data was intrinsically linked. They created highly interlinked information, so a vital points to a patient, points to a vital type, points to a representation of a provider. That provider also wrote a prescription which points back to a patient, he wrote it at a location. Everything is this big web of interlinked data. And so a lot of institutions, when they decided, oh, they're going to get rid of that, with the big vogue of relational stores in the 90s, we'll just get rid of all this mump stuff we have it in. The DoD, for instance, spent over $6 billion to get into Oracle. They have the biggest unindexed Oracle table in Alabama. It's the biggest Oracle table in the world. And it's a bear. You're in Bagram Air Force Base, and everybody knows this. You're in Bagram, well, he doesn't maybe know this one, but if you're in Afghanistan in Bagram, you dial back to Alabama. And it's really, really slow. Now, also the nature of this highly interlinked data didn't suit the relational form. They had so many things trying to link to each other. And to this very day, underneath that $6 billion system runs the original mump system that Tom actually designed, CHCS. The problem with the original systems, in part, was unlike relational, and you can imagine being at some DoD conference and there's PowerPoints and people are showing the latest and the greatest. The mumps, these systems didn't come with an SQL, a query language, and they didn't have a natural serialization format, a natural way for you to take the data out and exchange it with somebody else. They were very fast at putting the data in there, but they weren't very good at getting collections of graphs of it and putting it somewhere else. So when you look at RDF, it's very good at that for highly interlinked data. You look at these systems, they literally have up to 1 trillion triples in one very small store, highly densely stored. You marry the two, and now you suddenly free up the majority of stored structured healthcare data in the United States, and you make it available in an interlinked, fully defined format. And another thing Tom said, not only is it this free-form interlinked stuff, but there is a metadata model, so there's two sides to this. That's something else I think Charlie said. You have two areas you can describe in RDF, which is quite unusual. You can describe the type of data. In other words, I can define what a vital type looks like, and I can have a concrete vital measurement. His height is this, and they're both capturable in RDF. These systems, whether it's Epic, Vista, CHCS, and the DoD, they all have that form. They have an ability to describe their metadata, the concrete data, and they all naturally fit into RDF. Now let me just show you that quickly, because we only have a certain amount of time. So if we go, as I said, vista.caregraph.info FMQL. As I click now, I'm going to be going to a live Vista system. This is the Vista EHR that runs in the Veterans Administration, over 200 installed instances, over 10 million patient records. Let me go to where? Okay, I'm going to go to the query maker. So let me pull up a query quickly, and I mentioned something about types. So the first thing I'm going to look at is a type. I'm going to go to the system. I'm not going to scare you with tiny font. And if I ask for it in HTML, because at least we can read that, we can now suddenly see what does this system think an allergy looks like. Now, by the way, just to show, I'm not, RDF can get quite involved. It's really a machine processable format. We can get this all back in RDF. I'm just going to quickly walk through the HTML version of that so that you can at least see it. And as I click, I'm going to a live system sitting in Houston, Texas. So basically, you can see here right off, as Tom defined it, this is typical. You'll see this in every system. You'll see it in standard FHIR models. You'll see it everywhere. Patient, reactant, what allergy type, the drug ingredients, the classes, etc., are all defined in this Vista model. You go into the DoD system, you'll see slightly different names, but basically the same arrangement, the same stuff. So from standards defining an allergy to how people, when they really had to implement systems, they all end up roughly with the same thing. There's only so many ways you can define an allergy. Like there's only so many ways you can define a prescription. So when you expose these systems, the first thing you realize is, wow, these things are already pretty standard anyway. in the sense of standard as in just common sense data arrangements. You don't have to be off in a room in a fine hotel and make up an ideal scheme because people have actually done it. It's really running in the systems already. You just need to add icing to that cake. Now to this model, if we look at a concrete allergy for a second. So here's an allergy of patient 9, as I said. Okay, let's not look at the JSON because you won't be able to read it. If we look at this, so Christopher Jones is allergic to lactose. He gets diarrhea. It's probably not that unusual. And don't worry about the names. These are all de-identified names because some of this data started as something else and you have to de-identify. That enter by would normally be a doctor's name like Dr. Kildare or something. And you can see that there's the drug ingredients are captured, the different classes of the drugs. Now another thing I wanted to just bring across. This definition, if we look at the RDF for a second, press properly, is specific to this Vista system. You'll see here lactose, you'll see here a reference within the Vista system to the resource that defines the patient, to the resource that defines the allergy itself. It's in 50_6-12222. That's literally lactose within this system. That's a URL for lactose in this system. But like any website that doesn't point anywhere else, if you simply expose one of these systems as a big RDF model, and we're talking here about 2,500 odd types of thing, all interlinked and interweaved, it gets pretty boring. First of all, it's not intrinsically interoperable. So the next thing you have to do after you expose is you try to identify those things in the system that are actually held in common with other systems. This isn't the only system with Dr. Kildare in it. It's not the only system with lactose defined. It's not the only system that knows about diarrhea, because they all know about diarrhea. So what we want to do is basically say, here's a record, this is this system's representation, and then we want to link some of it out. And the extent to which the data is interoperable from this concrete system, and this is a measurable thing, is how much it links out. You can literally just run a crawler, do a link count. How many links are dead ends in the system? How many link out? That quantity gives you how interoperable your data is. No one in a standards group tells you, it's just a number. Crawl, you count. And what it really amounts to, if you look at the concrete one here for a second, signs and symptoms. Diarrhea, inside the system. Diarrhea. is, as I said, if you look at the local representation, this is the local representation, right? Is 120.83-9, right? If we go back outside this local URL and we say, this system actually knows it's got a copy from a central terminology service of that representation. So we can go from diarrhea local using a same as link out to a terminology service which has the standardized VA representations of these things. And all 200 VA systems, just with same as links, their data all links together. When you think about a crawler, you want to crawl across, God knows where you want to do this, we crawl across all the diarrhea entries. You're really interested in this. I don't know why I put that one in there. But you're going to crawl across it all. You simply want to go from their central terminology service, you see schemes, care info, VA, that's a VUID it's called. Basically that's a unique URL for diarrhea in the VA. And you can go to every one of the 200 systems and pull up that. They all federate. So you're no longer locked in the exposure of one system. You now have diarrhea from all of the systems. I've never said that phrase before. Just in case. Now lactose, think about this. That's a dead end with diarrhea. That in the terminology service didn't link out to say snowman diarrhea. Because again, all the terminologies know. But take something like the drug. So we look at the generic for lactose. We link out to the VA system. In this particular case, in this ingredient, in the terminology system, the VA terminology system knows, and there's its URL on top, it happens to know, hey, I'm the same as this OREX norm designation. So now you have a bigger tree, and now I can basically go to all the lactose. I can see everything that links to lactose in OREX norm through the VA, the DoD of their own representations, all down into all of their systems. And they're all linking out through extremely simple exposure. There's no layers here. There's no web service. There's no bus. There's no event exchange. It's just data linking up with data. And what you try to quantify as you improve that linkage is how many of those things link up. And the more you have dead ends, the less interoperable. The more you have links like I just showed, the more interoperable you are. So you can imagine if DoD or EPIC data, ultimately when they're using lactose as an ingredient, end up pointing to the same RX norm, however indirectly, they may go through many steps, then they in one web have linked up together. And that is one approach towards delivering interoperability with RDF. You expose the data in the system, you then expose how much of the system is actually common data, and then it all naturally links up. The last thing, and I can click on it for you, but this is not just about terminologies linking up. If you think about a pie, these systems, they have patient data, the individual patient's prescriptions, etc. They'll have the terminology information. We've just been looking at an example of that. Then you have the slice that deals with the providers of that information. If you're in the United States, every hospital, clinic, and provider has a government-issued NPI number. They have a unique portable identifier. So one of the shames or almost disgraces with all the money we've spent on meaningful use exchange in the last 5 years is this actually isn't that hard. We've already spent the money standardizing how you identify drugs and how you identify people and institutions. This should just link up. And the big impedance mismatch has been not exposing it in a common form, treating terminologies as if they need a different medium than patient data, treating provider information as if it's something CMS keeps itself. Put it in one medium, link it up, and you will have solved the problem, or a large element of that problem. Okay, is that good enough? Is that short enough? Thank you.